Hi, good morning, students. Here. Okay, let's start our new class. Nothing but you're discussing about the polymers only. You know very well about the polymers. Generally, polymers give formulation by combination of the monomers only. Various monomers are combined, they form a polymers. Classification based on their molecular force of attraction. Do you know very well here that each polymer containing of the monomers are there? The monomers they have some force of attraction in there. Based on that force of attraction, the polymers are classified into the four types: elastomers, fibers, thermopolymers, thermosetting polymers. Elastomers fibers is there. Here we are discussing purely molecular force is there. Elastomer means elasticity, stretchable property is there. Fibers nothing but a thread is there. Thermopolymer, thermosetting polymers, we are discussing especially about the thermal response towards heat only. Clear? In this one is we are discussing right now. Yeah, look at it. We are discussing about these polymers only. So let's go the elastomers only. What is mean elastomers? Means generally they are solids only. You just consider rubber band is solid only, no? They have what is they generally they are the elastomers solids only. They have elastic properties there, no? Next one is that here there can be cross-linked polymers. They are the cross-linked polymers. Do you know very well about the cross-linked polymers we discussed in previous is there, no? So if you have entered, just go for the back side, just check out here. It's a cross-linked polymer only. In this one, elastomers, two example is there here, Buna S rubber, Buna N rubber. Look at the Buna S rubber, Buna N rubber is there. Now here, rubber is they will take, they will add some styrene. Here what they are, the acrylonitrile they are adding. So look at there now, here one poly, look at there, you just consider there, this is a copolymer. Copolymer means combination of the two different polymers, two different monomers only. This is called copolymer only. So this copolymer is there now 1,3-butadiene is correct one. This is same one, but for both polymers only. But here styrene they had used acrylonitrile only. Next coming to the here, next kind of neoprene also is there. We'll discuss neoprene also. Elastomers only. Next one is fibers. Fibers nothing but threads. They are the solids only. You know where nylon wire is there is thread only, you know. But here look at what difference between elastomers and fibers means. In fibers, look at there here, they are molecules held together by strong intermolecular force of attraction. They have strong intermolecular force of attraction. They cross. Look at the here, the just consider cross linkers are more. They cannot be stretched easily. If you pull the nylon wire, can you stretch? No problem. No, you cannot stretch that one. No, that's called as the here. Like this one is generally the fibers. No, these threads are there. Nylon 610 also discussed previously. So here these are regarding the fibers only. Elastomers, fibers means elastomers they have a stretchable property. Fibers and the thread they can't be stretchable. So let's go for next one. Thermoplastic polymers are there. These are the linear or slightly branched long chain molecules. They can be repeated soften and hardening. Sorry, they can for suppose if you heat the thermoplastic is there, no, it becomes soft on heating and again becomes hard on cooling only. Example polythene, polystyrene, polyvinyl chloride only. Thermosetting polymers are there. These are the cross-linked polymers are highly branched is there. We cannot mold, we cannot break easily. Unbreakable kitchenwares are made up of the thermosetting polymers only. Bakelite, glyptol. Next one is coming to the most important thing is rubber. Look at this rubber only, no. You know, so rubber here, how they will take wood part is there, they will cut the part is there, no. This plant secretes some alkali will be that alkali. Look at here, just imagine here. When you cut what up in there, some alkali white color liquid is coming, no. That liquid they will collect. This is nothing but natural rubber. Clear? This is nothing but natural rubber only. So it can be classified in two parts. Will be the one is natural rubber, next one is synthetic rubber only. Natural rubber means the rubber which is obtained directly from the plant. Clear is there? We discussed even previously. There no here. What happened there when the plant we cutted, some alkali is coming. They will add small amount of the without adding chemicals. Also, you will get the rubber only. It's very soft. You cannot make a tire. Something else is there no. So this is natural rubber. Next one synthetic rubber only. Coming to the natural rubber is there no. The natural rubber is there no. It is obtained from the milky secretion of the latex. Some nothing but some liquid is produced by the plant wood pot. Various plant, but only important commercial sources is a natural rubber is there. Sometimes it's called as a para rubber. Natural rubber also called as a para rubber. Because generally it coming from trees only. Next one is synthetic rubber only. Synthetic rubber means just imagine here the natural rubber is very soft, alkaline, slightly soluble in the water. Okay, generally it will be slides all up in the water, okay, easily flexible. Okay, no. So what I mean, the whatever the rubber we are using in a daily life, but vehicle tires are there, no, it is very hard. You do know very well, no, vehicle is moving how many thousand kilometers, of the tire will be safe only. So what is this called? Synthetic rubbers only. From natural rubbers they will prepare, some other prepare synthetic rubbers only. These are the two types synthetic rubbers is there. Then generally they will add sulfur to the natural rubber, they will make a synthetic rubber only, BNIS, BNIN, it will become here. During the vulcanization process, now what is mean vulcanization process means they will take natural rubber, they will add small amount of chemical. When you add small amount of chemical like a sulfur, they look at the chemical process for converting rubber into the more durable material by adding up sulfur. Okay, now what I mean there, generally natural rubber is soft, easily generally soft and flexible only. They cannot use, I want make strength and I want use for regular purpose. So I am adding a 5% sulfur for making up tires. You remember general tires, cycle tires are there, 5% sulfur they will add. 20 to 25% of sulfur for ebonite rubber. Because molded rubber is there, no, 30% for the battery cases only. So by adding of sulfur, they will use the preparation of the vulcanization rubber only. When you add vulcanization rubber, what happens there here? First of all, understand why you need to go for the vulcanization process there. Generally, go for the properties of raw rubber is there. No? Properties of natural rubber, it is very soft. First point is very soft, sensitive to heat. On heating, it will be very sensitive. Elasticity decreases over time. It cannot be stretchable. Easily we can break into small pieces only. Easily oxidized by the air molecule. Natural rubber formula nothing but 2-methyl 1,3 butadiene. Look at the nomenclature 1, 2, 3. 2-methyl 1,3 butadiene. This is called as isoprene. Polyisoprene. This isoprene is there. Like these molecules, many molecules combine, they form a natural rubber. Look at here, just imagine this is a isoprene units are there. These isoprene units are there. The sulfur will be attached. Cross linkers are formed because of this sulfur only. This is called vulcanized rubber only. Look at difference between natural rubber and vulcanized rubber is there. Natural rubber is soft. Vulcanized rubber is very hard. Natural rubber is less elastic nature is there. Vulcanized rubber is more elastic nature is there. Natural rubber is non-heated resistant. On heating it becomes to molded is there. But the vulcanized rubber is highly resistant. Highly resistant only. Then natural rubber is having low melting point and boiling point. Okay, now for synthetic vulcanized rubber is a high melting point and boiling point only. Easily oxidized natural rubber. Synthetic rubber, vulcanized rubber is resistant towards oxidation. Look at the natural rubbers are, it will be like that. Look at that. No cross linkers are there. After adding the sulfur will be added here. They will become very strong one. That's different from the natural rubber and vulcanized rubber only. Very, very important. Look at this. Next one, go for the natural rubber is there. No, it is linear polymer. Isoprene units is there. 1,3 butadiene. Already we discussed about natural rubber, nothing but isoprene units are there. Okay, here various cis polymer polyisoprenes are cis compound. Cis compound means it will be both are in same direction only. Here chains are held together by the weak van der Waals force of attraction and has cool coil structure will be there. Okay, coil will be, cis form will be there. Next one is coming here. The next slide is there. No, some other polymer also is there. No, vulcanization and merits of vulcanization process there. Because vulcanization of rubber is to improve the physical properties of natural rubber. It is heated with the sulfur and an appropriate temperature. Okay, temperature is also mentioned 373 Kelvin to 415 Kelvin. Very, very important. To improve the physical appearance of the natural rubber, they will add sulfur and heat at 100 degrees Celsius, 100 to 200 degrees Celsius only. Called vulcanization process. On vulcanization, sulfur forms cross linked between the two different polymers, isoprene units. Thus, this rubber gets stiff and become very strong only. Synthetic rubbers are there. Next one, synthetic rubbers are there. No, yeah, I want better strength is there. So what happens? I use synthetic. You just mean nylon tires are there. No, nylon tires are there. No. The Apollo tires are different tires are there. No, look at that. Synthetic rubber. These are the either homopolymer of 1,3 butadiene derivative or copolymer of 1,3 butadiene. What is a homopolymer means? No, only 1,3 butadiene is there. No, that is called homopolymer. Copolymer means two molecule, 1,3 butadiene plus styrene, 1,3 butadiene plus acrylonitrile only. This is nothing but a synthetic rubber. Very, very important for the board examination. Next, coming here, some commercial important of polymers is there. No, look at the students is very, very important. BNIS rubber, BNIN rubber, BNIS rubber. Look at the mention is there now 1,3 butadiene is there. Already discussed about 1,3 butadiene plus acrylonitrile. Acrylonitrile nothing but here look at there. No, don't confuse here. CH2 double bond CH2. Imagine one hydrogen not replaced by the cyanide group. Look at this called acrylonitrile. What happens? Just imagine here double bond is there no. The double bond is here. Double bond is there no. After formation of polymer, this double bond is shifted to here middle carbon. Look at here. And what happens here? Terminal carbons are become single bond only. Look at this carbon attached here. This is become single bond. This is become single bond. The double bond will shift here. Look at this one is. This is called Buna N rubber only. Used to making of the oil seals and tanks lines only. They use making of oil seals. Very very important. Just try this equation twice. Next in Buna S rubber styrene. You know styrene is there no. Styrene nothing but here. Look at there here CH2 double bond CH2. We add cyanide. This is Buna N rubber. If we add styrene. Look at this styrene nothing but benzene here. Look at it, what will get the Buna S rubber only. This is called Buna N rubber and Buna S rubber only. Let's say some commercial, just remember some commercial importance of polymers only. Look at the polythene bags are no polythene. CH double bond CH2 become polymer only. Clear is there no? Look at use it for the toys and flexible pipes, dustbins, bottles, pipes. All is made up of polythene bags only. Polypropene. Look at propene. Look at this one is CH double bond CH3. What happens here? It will be okay. This carbon is attached to some other polymer. This carbon was attached here. Look at here. This is called polypropene only. Remember here is there no here small difference is coming. Just imagine here this attachment will be there. I will make very clear. So look at here. This one is then here. How it will behave like a just imagine CH2. CH and here CH3 will come CH3. Why valence is 3 only 4 only already 4 is over. So this one attachment will be there. Attachment will be there. It forms a polymer only. It's coming as a polymer. So is the polyisoprene units are there. So go for next one is the next polymer also important. Look at here the what is next polymers are there here. Polystyrene. Look at polystyrene. I discussed on polystyrene nothing but here CH2 ethene is the one hydrogen replaced for benzene called styrene. Look at attachment will be there. Okay, attachment will be there. Here benzene attachment is there. Called polystyrene only. Polystyrene used as an insulator, wrapping materials is there. Next you know PVC pipes are there. No? Polyvinyl chloride. Look at vinyl chloride. Nothing but here just imagine everything is the alkenes only. Addition polymer. CH double bond CH2 Cl is there. After polymerization single bond is forms here. It's N molecule will be there. Look at attachment polyvinyl chloride and PVC pipes are there. Next one is that here neoprene is there. Neoprene units nothing but here 2 chloro 1,3 butadiene is there. Neoprene isoprene difference is the isoprene CH3 group is there. Chloroprene this one is will be there. Polymerization what happens here also 2 pi bonds are there. They shifted to this carbon atom and to these 2 terminals are attached here. Clear? So N is called neoprene is there. Used for the manufacturing of the conveyor belts, okay, gaskets, hoses. Look at them. Generally gas pipes are there no. They are made up of the neoprene units only. Teflon, you know very well Teflon is very very important. Tetrafluoroethylene. Here look at there, just imagine here ethylene molecule 2 hydrogen atoms are replaced by 2 fluorine atom. Catalyst high temperature is there, they form a tetrafluoroethylene used for making up the non-stick cookware surface area is there no. Generally you know very well for cooking purpose we are using non-stick cookwares are there no. That non-stick cookwares containing of the Teflon. Next one is nylon 66. Nylon 66 you know very well adipic acid, hexamethylene diamine only. Adipic acid formula is called CH2,4 CHCOH is the hexamethylene diamine. At 553 Kelvin's temperature they will form a nylon 66. This is called condensed polymer only. Nylon 6 made up of only one type of polymer. This is nothing but caprolactam. This is called as caprolactam. Well, look at this caprolactam is amide is there. C look at the NH is there. C double bond. How many carbon atoms are there? 1, 2, 3, 4, 5. Okay, along with this one 6 will come. On heating what happens there here? Generally they will go break will come here. They will attach to some other molecule is there. Look at there. This called as a nylon 6. Nylon 610 only. Generally they use for the tiring of the fabrics, ropes also they use. Next one is bakelite. Bakelite is it is prepared from the phenol plus formaldehyde. Do you know what is mean phenol? You know very well phenol. What is phenol here? Just imagine here the look at this one backlight made up of this one. Backlight is a copolymer. Copolymer made up of two monomers are joined together by releasing some water molecule. Look at this, just phenol. This is called phenol. Benzene contain on OH group is called phenol. Formaldehyde formula is equal to H2C2O. What happened here? One oxygen atom is replaces. One oxygen atom is replaced here. One oxygen is leaving from this carbon, and here one oxygen atom leaving from here, and two hydrogen atom. From here hydrogen atom removing, here hydrogen atom is removing. Backlight remember means just imagine here your tiffin box are made up of backlights only. Backlights nothing but phenyl form. It is prepared from the phenol plus formaldehyde, used for making up the combs, electrical switches only, handles of the utensil like the material cooker, something else is there, no computer disk. This is also made up of these things only. Look at why you are much more focusing on rubber means rubber using for the rubber sheet, making up a recycled rubber is there. Look at the rubber sheets they are using for that. And next one is there here, you know very well. Generally rubber is molded form. Different type of rubbers is there. Molded form is there. Look at there now we are using the most rubber common in daily life is there. Look at rubber paints also is there. Rubber paints also available. And next one is there rubber flooring. Look at the flooring is there when child is playing here without getting hurt is they will use some rubber flooring will be there. This is a rubber flooring. Some mats also made up of the rubber only. Look at this also household is there, no? This is also made up of the rubber only. Plastics are made up of rubber only. Household utensils. So look at the using rubber flooring in. Next one bridge constructions are there, no? Bridge construction they use. Expansion of joints also, windows also, pipes also, roofing materials also, sound insulators also. They use rubber only. This is regarding rubber. Okay, thank you.